Hello everyone, here I am Sagar Wadar and welcome back to the all. Here today we are going to continue our discussion about the light reflections and refraction chapter, and the second part we're discussing about the terms associated with the spherical mirrors and we understand deeply. Okay, today we are going for image formation by the spherical mirror. Okay, then how images are the forming by the spherical mirror, because whenever you are going at your home, it means at your home you have a mirrors. That mirror is named as plane mirrors. So your images are formed inside the mirrors. Okay, but you don't aware about much aware about the image formed by the spherical mirrors. So that questions arise, how about the image formed by the spherical mirrors? We will understand in the previous or the after the few slides. How can we locate the image exactly doing without experiment? It means without mirror we can say if object is here, then image form will be here only. So this sort of questions, the answer can be only do by some rules. If you know some rules, sort of rules, then and then you can answer. So today, whatever we discuss is not about the image formation by the spherical mirror. Actually, it is all about the rules for formation the image by the spherical mirror. Okay, now don't see this part yet. Focusing here, if you want to understand the today's discussion, then you should very clear about what we discussed in a part number 2. Okay, there we discuss about the terms associated with the spherical mirrors: pole, principal focus, center of curvature, radius of curvature, focal length, and all about principal axis. And then pole is the center of the mirror, principal focus is the point where our parallel ray is coming and then reflecting, and then focus point is your principal focus. The c, it is radius, or c, it is center of curvature. It means it's the center of the sphere whose from where our mirror is cut out. Okay, and these are the basic terms. So you should go for the part number 2 video, then understand and come back to the here. Then our first law for the formation of image, generally they are asking in a board examination, write the rules or the write the sort of criterias when the rays are falling in such a ways. So the first, if you yes, in the first diagram, please see in the first diagram, here we have a particularly concave mirror. It is a curved inward, so it is named as concave. In a second diagram we have a convex mirror because it's a curved outwardly curved, that's why. Okay, now please focus here. The here, this line is called principal focus because it is the imaginary line which is passed through the point C, F and P and etc etc. So this is named as principal axis. Okay, now the object is there. Object means is anything from where lights comes. Okay, so this is our light ray. Okay, then don't see the text part, don't see. First understand what I am trying to introduce to you. When the any light ray sorry when any light rays are parallel to the principal axis, you can see the principal axis here, and it is parallel to the principal axis, is fall on any spherical mirrors, it is reflecting in a such a way, because the mirror only can do reflection, don't do any kind of refraction. So the reflection is here, and this reflections in a such a way, then it only pass through the principal focus F. So the our first discussion, first rule is, any parallel rays to the principal axis, any light ray whose parallel to the principal axis, it must reflect from the spherical surface, and it must pass through the principal focus F. Okay, this is all about concave. If you want to see in the convex also, it can be same for it. The this light ray is coming, and it is diverge. So two things are you have to understand now. Concave concave it always rays are converge, and in a case of convex they are diverge. So it is awaying the rays are not meeting. In this case you can able to see that concave mirror we are using. So the rays are fall on the mirror, rays are fall on mirrors, and they are all are converge, they are meet, they are come close. So they it is a converging mirror only on the concave mirror. The second name is converging mirror, and then convex mirror second name is diverging mirror. That is also one of the good MCQ, please see. Okay, now so why this rays when fall on the concave mirror it is like, but like that only reflect, because you can able to see the curve of the mirror in a such a way, that's why it is a reflecting in such way. Here the convex mirror is a outwardly curved. So if it is okay, suppose you are throwing ball, then if you are throwing ball in this direction and this surface is curved in such a way, then which path it will follow? Only this path. So here also the light is fall on it and it is reflecting. So the image, okay, then you can ask me then how it is parallel to the principal axis but it is not passed through the F. But if you extend backward, then it is a mid to the F point. It is a not a mean only the F point only about the one side. It is also here also F and here also F is the same distance from it. But for the particular concave it is a left to the mirrors. In a convex it is a right to the mirrors. Okay, then you should know about PF and PC distance and all that. It is all about discussed in the part number 2 video. Okay, the first rule is clear now because I am spending more time here because it is important. When any parallel rays to the principal axis is fall on the spherical surfaces, then it reflect in a such a way so it should pass through the principal focus. Okay, this is first law. Second, when any rays are passed through the F, reverse. The second rules is just a reverse of rules number one. What we discuss in the rules number one, when rays are passed through the when rays are the parallel to the principal axis, then it will pass through the F. Now it passed through the F, then it should be reflect in such a way so it will be parallel to the principal axis. So here also you can see in the first diagram only you can see. So the light rays are coming and it is passed through the F point, please see here. Then after the falling on the reflecting surface it should be reflect, so it's reflecting in such a way it is parallel to principal axis, reverse way. Okay, here also you can see the rays are coming towards the F point, so it's reflecting in such a way so that this and this. Okay, okay, this is all about second. What about third rule? Kindly see here. When the light rays are coming in such a way, if it is passes through the point C, what is point C? Center of curvature. Center of curvature means what? It is a one sphere from where our mirror is come out. Okay, that point C is the center of the sphere, the C. Okay, the when rays are passed through the point C, then it reflecting in such a way in the original path as what it's follow earlier. So it is come back on own position, own line which followed. So the read that what I write. Rays passing through the center of curvature point C of a concave mirror are directed in the directions of the center of curvature of a convex mirror. Okay, after reflection it reflected back along the same path. This is very important thing. If it is parallel to the principal axis it passes through the F. If it is passed through the F it will be parallel to the principal axis. And what is third? If it is passed through the radius of curvature, it is if it is passed through the center of curvature point C, it is follow the reflection path is same as what earlier path it has. Okay, fourth rules. Now don't see anywhere else, seeing here. This already we discussed already in a rules. If you know the rules of reflection, it is very easy for you now. If the rays are not fall on F, if rays are not fall on C also, if rays are directly coming towards to the P point at some specific angle. It can be this also, it can be this also, it can be this also, but here is specific this we are taking. Then this your I is called, if go back and revise, I is called incident angle, and then light is reflecting from there, it makes angle through the principal axis is called reflected angle. According the rules of reflections, laws of reflection, this angle should be same. If it is fall at the 45 angle, then this reflecting should be also, this angle also should be 45. So the I and R is same. So here also you can able to read it. In a convex is same. Ray incident rays are coming towards the point P pole of the mirror, reflecting obliquely. The incident or reflected rays follow the laws of reflection. And what is the laws of reflection? Laws of reflection is tells us what angle makes by the incident ray, the same angle should be on reflected ray. It means angle of incident and angle of reflections are same. Remember that whatever we are discussing, the whatever we are discussed here all where the reflections are only can happen when the laws of reflection each followed. So you should very well clear about the laws of reflection. Go to the part number 1 ppt, our discussion. Okay. And yes, today we are not discussing about the formations, image formations from the spherical mirror, but you should know for the basics the formations of image by the plane mirror. So here you can see that mn, the blue line, is your our mirror. This is also at your home you have plane mirror, and here this AO, it is you are standing in the front of the mirror. This is very clear now, please. Here mn is your plane mirror, and your this is AO is your you are standing in the front of the mirror. Okay. Now when rays are, because the sunlights are fall on you, you have a tube lights and all that you have, then lights are fall on you and then they are reflecting from your body to the glass, it means mirrors. Then what happened, the first rays is fall on the mirror. Okay, it's fall on mirror by the 90 angle, so it is reflecting back in the own position. When the second rays is the fall on the mirror in such a specific angled, so as per you know the reflections angle should be same as incidence, so it will be reflect, so it is coming and it's going in this direction. Okay. Now one thing you should understand, please. There is a not two rays, not a three rays, not a four rays, thousands of rays are there, light rays per. But for the image formation, our task in this later chapter also, our aim is image formation. For the image formation, you should require minimum two rays. So here we are discussing this is first rays and this is second ray. So these two rays should be meet at some position there our image formed by the object. Okay. So as you can see, this two rays should be meet. Okay, the one rays is coming and that is reflecting and going in this direction. Okay. Now what about second, it is starting from the here and then it's going and this is going here. So the first ray is going in this direction and second in the going in this direction. Oh, they are not meeting at all, they are going in very opposite in sense. Okay, so then image will not form. But if you are extending your ray backward to the mirrors, so if it is a backwarding I'm extending and this reflect, yes, you should extend your rays which is reflect. Okay, here the incident rays in this, but the reflecting also this, so this I'm reflecting surface I'm extending backward. Here the incident rays and this is reflecting, so the reflecting I am extending in the backward side. Yes, they are meeting at one point, that point name is A prime, and that point is the point where our image form. Here the rays are not actually meeting in the front of the mirror, so we have to our rays extending backward to the mirrors. That this type of image is named as virtual image. Actually there is a two type of image, real image and virtual image. For our from the today discussion, we are not going in the detail. After that we will understand in detail. But when our rays are not actually meeting and we how to do forcefully at the backward extending, then this formation of image is particularly virtual. So the image formed by the plane mirrors is virtual. If you see the size of the object AO, if your size is 5 foot, then your image, which is if you are seeing inside your mirror, it is same as exactly what you have. Okay, then this, if you have a 2 meter size, if you have 1.5 meter size, then it will be 1.5 meters. So the same size is formed by the plane mirror. And it is a erect. What is the mean of erect? If you are standing like a legs and head, then your image is also head and leg like. It means as it is what you have on the front of the mirror. This is called erect image. If you are standing as it is, then image will not like a, it is a downward, is your legs upward and head downward. No, always image formed by the plane mirror should be